for all of you. Thank you very much for the possibility to be here and presenting our contribution. You can see that our team is from more countries, and for us it was very, very interesting cooperation. First of all, I would like to say big thanks for Chinese Ministry of Science and Technology and Research and Development Agency from Slovakia, and also KIGA agency, and last but not least for Thomas Bata University in Green, because we use the laboratory of this university for building this information system. And our motivation is, we do not inherit the earth from our parents, we borrow it from our children. This is a sentence of Antoine de Saint-Exupéry, and also the big person, David Frederick Attenborough, say we have a finite environment, the planet. Anyone who thinks that you can have infinity growth in a finite environment is either a madman or an economist. Sorry for all economists which are here and is right hearing me, but for us like engineers and electro scientists is very, very nice. So we would like to start with very simple example for our philosophy, and I think probably all of us, we are good in making some evaluation of cars. So we selected two cars. One first, letter A, 5 years old car, diesel, and 130 grams of carbon dioxide per 1 kilometer, and B, new electric car. So when we draw the consumption or creating of this carbon dioxide, we can show on the horizontal axis the 100,000 kilometers. This is lifetime of the car, and on the vertical position we have tons of carbon dioxide equivalent. So it's very nice, and so we can say, okay, in first view, this product, an electric car, is much more better like my old diesel. So we can but we can realize this one. For example, this is there are 2 weeks old information. For example, in France, the energy mix is in way that they can charge electromobiles with 11 grams of carbon dioxide equivalent per kilometer. In Germany, 91.2, and in Poland, 167 grams carbon dioxide equivalent per kilometer. So when we selected the higher and the lowest border, we have 2 borders for electromobiles in Poland and in France. The difference is because in France they have so many nuclear power plants, and in Poland they have many electric plants by coal. So Germany, I will comment later. So, but this is not all, but because we are evaluating the using of the product, but not manufacturing, and this is also very important. So we can say that when we have 6 tons of carbon dioxide equivalent for production of both car, but we have also for this battery 150 kilowatt hours battery. This is 20 tons of spent carbon dioxide. So we postpone these 2 cars, electric cars, to this level, and now we can see that in maybe 170 thousand kilometers, its break point from which the electric country in France will be more ecological. But we forgot other things. But because today's batteries limit of 200,000 kilometers is really very optimistic. But we will use it for one battery. That means after these kilometers, we need replace the battery, and we have this position. And this is for Germany, but please be patient because this is only in optimal weather conditions. Sorry for my mistake in word weather. Because the energetic mix of Germany have many solar energy and wind energy, and then there are days without sunshine or without wind. They must start it the coal. But okay, so this is very beginning of our thinking, because we forgot to mention cars transportation to the customers, energy consumption for ecological recovery of car body and liquids, and energy consumption for ecological recovery of battery materials. And we don't mention economic and environmental circumstances of the life cycle for this all. So, and this because for general people, they are looking for the problem from the end. We are now coming to start and to try in phase of the design of project, thinking about it and make a very good decision before the finalizing of the project of the product project. So the most important point of our motivation is to develop information system for support of objective sustainable design and manufacturing of the product. And what is the necessary condition for us? We have two conditions for this information system: flexibility and efficiency, because very complicated system is so terrible for producers, for designers. They hate such systems. So we would like to do it in this way. So we prepare the system for product and processes design and operation. We can see in this very similar scheme that this is really from product design, and on this material production, transport, use, disposal, they are the paths of life cycle according ISO 14040 and other. So we were in this mode, and we prepare system which must be cooperative on product design and on starting of manufacturing design with cooperative CAD/CAM systems for creating models, NC programs, and analysis and all. And the second, this developed information system is oriented for manufacturing design, work study, and real-time information. And all of these stage from product design to manufacturing design are under assessment of the environmental impact. So in our approach, we use United Nations agenda, Kyoto Protocol, ISO standards, PAS 2050, and also economic efficiency standards and product safety and use regulation. And this philosophy is in this way. The first design of the product or the process is under very approximative but fast methodology of Professor Ashby, when we use only carbon dioxide equivalent for the evaluating of the many suggestion of the product or the process, and after selecting of the best product or best processes, we can use the time consumption life cycle assessment according to ISO, and we can see that resource consumption and emission inventory and impact assessment are evaluated. So this philosophy was described before, and very nice example. We selected 5 technologies for one selected product, and we try to evaluate this technologies or processes. So after filling all information about these processes for this one product, we obtain a relation of production cost per piece on quantity produced. So we can see that every color from NC machining to DMLS have some characteristics which can be now very informative for us, but only from point of view of cost for production. We don't mention here the managerial and production overheads, transportation. Here was only material, personnel, machine, and special equipment income. And also our outputs can be in absolute and relative share of production cost in relation to production size. This is very nice tool because we can see on the upper graph for two technologies. I'm very sorry, but it's covered for me here. So this is one technology with price, and the second, and down we can see the sharing of material and machine costs and personnel costs. So the most important part of this information system is this one, because this is comparison of all processes, technological processes for this product. We can see that this violet is production costs. The highest is for DMLS production technology, but this energy consumption is green. It's for me the information about the environmental properties, CO production, and aggregated value. Two very important information for me. First is no white. That means we use only some summary of the economical and ecological influencing, and aggregated value is with weighting by, for example, when ecological aspect is more important for me, it's on higher weight, and it will be pushed the economical point of view. So the developing of society, bringing new criteria for production activities, and the activities are must be more complex. So we have optimized from many points of view for good results, and sophisticated procedures and tools for support of these all activities are needed. So we developed information system for product and process design and product and process life cycle. Offer very flexible creation of more products, process suggestions, and optimization according to the requirements, and it can serve as a strong support. So very simple scheme of working. For example, for us, manufacturer segment can be part, sub-assembly, assembly. It can be prepared in many process plans. Every process plan is divided to phases, and every phase is divided for cycles, which can be like operation. And so now in this system, we have some spider, and we are able to select the best phases to collect totally new process plan to be more efficient and environmentally friendly. So big thanks for your attention from all of my colleagues on this presentation.
Thank you.